onto molecular formula. So when you have the empirical formula of something, for example, glucose, which its empirical formula would be CH2O, we can, if given other data, find the molecular formula. So the molecular formula is not the lowest whole number ratio. It is what the molecule actually looks like. So an actual molecule of glucose has 6 carbons, 12 hydrogens, and 6 oxygens. Okay, covalent molecules do not need to be reduced into their empirical formulas. They can be bonded to a whole bunch of different things. So that's why we're focusing on this for covalent molecules. So to determine the molecular formula, what I have to give you is the molecular weight, or the molar mass, or the formula weight, or whatever it may be. I have to give you that molecular weight, which is something you can find in the lab. And so what you're going to do is you're going to use this equation, which is not much of an equation, but you're going to take that molecular weight and divide it by whatever the empirical weight is. So find the mass of, if we were talking about glucose, CH2O. If you do the molecular weight divided by the empirical weight, you are always going to get, a whole number. You don't get a whole number, you did something wrong. Okay, so you're going to get a whole number. And if I was doing glucose, that whole number would be 6, which, if you remember, was the number that I divided all of these by to get the empirical formula. So to get the molecular formula from CH2O, I need to multiply all those subscripts by 6, and I get C6H12O6. So I'm going to show you how this works. In example number 7, I've got a percent of this, percent of this, percent of this, which means I can find my empirical formula. And I give you the molecular weight is 176 grams per mole. So I want you to find the empirical and the molecular formula. Now, I recommend finding the empirical formula first. That is my preference. If you do molecular first, that's also fine. But I'm going to go through how to find your empirical and then your molecular. So empirical, just like before, I start with my masses, which were my percentages. I just turn them into grams, divided by molar mass to get to moles. So I get this many moles of carbon, this is hydrogen, this is oxygen, divide them all by the smallest. So this one, I get about 1. This one I get 1.35, which is not close enough to 1 to round. And this one I get about 1, or that one is exactly 1. So I have 1, 1.35, and 1. Now, really the only numbers that you're going to get when you do this is like a 0.5 or a 0.3333 or a 0.666, right? A 1/3 or a 2/3. So we would need to get rid of those by multiplying by 3. So I would do this times 3, this times 3, and this times 3, which then would give me a better whole number ratio. So my empirical formula, once I do that, is C3H4O3. Now, I know this is kind of hard to spot, so if you're not sure, make sure you ask me a question about it. But if it's like 1.3 something, you can assume that that's a third, or 1.6 something, or 1.7 something, you can probably assume that that's a third. Okay, so this is my empirical formula. Now, to find the molecular formula, I'm going to do the molecular weight, which I have to give you, 176 grams per mole, divided by the empirical weight, which I do have to calculate. So 3 carbons, 4 hydrogens, and 3 oxygens is right here, 88 grams per mole. So this is the molecular weight from the problem. This is the empirical weight. So I do 176 divided by 88, and I get 2, which is a whole number. Again, if you do not get a whole number, then that means your empirical formula was messed up somewhere. So go back and look at these decimals, look at these numbers, and make sure that you did it correctly. So I got 2. So what that means is the molecular formula is double the empirical formula. So if this was C3H4O3, then my molecular formula is C6H8O6. And if you want to double check yourself, all of these add up to 176.